Hello everyone, welcome to the digital electronics class. In this presentation, we will discuss the T flip-flop, also known as the toggle flip-flop. In the previous presentation, we saw that when we have to only store the data, we use a D flip-flop. In JK flip-flop, we overcome the not used state in SR flip-flop, that is the 1-1 state, that is when the value of S is equal to 1 and R is equal to 1. In that case, we are having the toggling action. Now we know that toggling is the controlled change of output from 0 to 1 and from 1 to 0. This we completed in the last presentation. Now suppose we want only toggling action. Then in that case, we will use a flip-flop which we call a T flip-flop. This T stands for toggle. So for this purpose, we will use a JK flip-flop to obtain the T flip-flop, just like we used a SR flip-flop to obtain the D flip-flop. But in D flip-flop, we had complemented the inputs. In this case, we will not complement the input. We will just give the same input so that J and K are same always. And this input we call T. This is the clock. So we see that this is a very simple flip-flop which we call the T flip-flop, which has been obtained from the JK flip-flop when we make both J and K inputs the same. Now let's see the truth table for the T flip-flop. Here we are having a clock and T as the two inputs of this flip-flop and Qn plus 1 as our output. Now when the value of clock is low, definitely this flip-flop is not going to operate, and so the state will be stored. So whatever be the value of this input T, the output Q plus 1 is going to be Qn, that is our memory, and this is well known to all of us. Now when the value of clock is high and the value of T is low, that is when the value of T is 0, that is clock is high and the value of T is low, that is clock T is 0, it means again we are having the memory, because in this particular case when T is 0, then the value of J will be 0 and the value of K will be also equal to 0, and whenever this happens, then we will have the memory. So in this case also, the value of the output will be Qn, that is same as the previous state as we have seen in the JK flip-flop. It means whatever be the previous state is stored and the output Qn plus 1 will be Qn in this case. So again we find that we are having the memory state in this case also. Now what will happen when the clock is high and the value of T is also equal to 1? This is the condition which we were looking for, because when T is 1, then the value of J is also 1 and the value of K is also 1. And so in this case we are having the toggle action. So the output in this case will be the complement of Qn. This is our toggling. So this is all we have to see in the truth table of T flip-flop. Hope everything is clear to all of you. See you in the next presentation.